Hi, today for the Applied Statistical Analysis course, I want to record a week 13 and a half lecture about odds and odds ratios. We introduced them briefly in the lecture for week 13, but I want to go into a little bit more depth. So the question is, what are odds? And if you're familiar with Las Vegas, you've done a lot of gambling there, or if you bet on horse races or anything like that, you've probably become pretty familiar with odds, but for the majority of people that are not active in those areas, we may not fully understand what odds are, and then an odds ratio is even harder to understand. Odds are just a ratio. It's the ratio of the probability of a yes over the probability of no. A few examples to consider with that ratio in mind. What are the odds of getting heads with a fair coin? So if we're flipping a coin and it's a fair one, I'm not even sure how you have an unfair one, maybe both sides are the same thing, I don't know. If it's fair, so you have heads on one side, tails on the other, what are the odds of getting heads with a fair coin? Well, we can just plug it into this formula. So the probability of a yes of getting heads is 50%, so 0.5. And then the probability of no, which in this case is just tails, the probability of that is just 0.5. So what are the odds? It's 1. In other words, when the probability is equal between the yes and no, you just get 1. A little bit trickier one, what are the odds of something that happens 66% of the time? So the probability of yes is 66%. That would mean the probability of no is 34% roughly, 33, 34. So if we put those in that equation, we get just about 2. So the odds in that case are 2. 2 to 1 is how sometimes people would say it. So the odds of getting something that happens 66% of the time is a 2 to 1 odds. With that in mind, big odds means high probability of yes compared to no. And then really small odds means low probability of yes compared to no. With this in mind, what do odds range from? Well, it can range from if this is 0, the yes is 0, then the probability of no must be 1. And in that case, 0 divided by 1 is just 0. So the odds are 0. When the probability of yes is 100%, then it's 1 over 0, which is not possible to do mathematically. So the odds are infinite, essentially. They're undefined. But as you get closer and closer to a probability of 1, the odds just get really, 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 really big. And they can get big really quickly. So big odds means high probability of yes compared to no. Small means low probability of yes compared to no. So what does an odds ratio mean then? Well, it's the ratio of odds, which is already a ratio. The odds are already a ratio of probabilities, so it's a ratio of probabilities. What you can think is, for an odds ratio, it is the top ends up being the odds when the condition is met, and then the odds when another condition is met. So one way of saying that is we are looking at the odds of something happening when one condition is happening versus the odds of something happening when another condition is happening. I think it's helpful to think of this in terms of an example. One that has a really big estimate is lung cancer when a smoker versus not a smoker. What we would have here is the odds when condition. So when the individual is a smoker would go on top. and then the odds when another condition, in this case, when not a smoker. And what that odds ratio would be comparing then is the odds of lung cancer when a smoker versus not a smoker. What's crazy is one estimate, and I have the link below, has it at 103. So let's piece apart what that actually means. That means the top, we can just plug in the value that we have. The top, we can say, is 103. That means the odds are really high when the condition holds, versus what happens on the bottom is, in this case, we could just put a 1 to make it the odds ratio 103. That means it's really small when not a smoker. And quite likely it's actually the odds of getting lung cancer when not a smoker is probably really small, like well below 1. And so the odds when being a smoker is probably around 1. I don't know. I don't know the field well enough. But what it means is that the odds when you're a smoker of getting lung cancer is 103 times bigger than the odds when you're not a smoker. That's a huge difference. So when you're a smoker, your odds are really high compared to when you're not. The odds ratio doesn't tell us the exact probabilities though, not directly. It doesn't tell us the exact odds. We just know the ratio between them. When we get that out of logistic regression, there's ways to get probabilities out. And if you go further into logistic regression, you're going to be able to do that for sure. Jamovi allows you to do that. One last thing to note before we finish this mini lecture is sometimes you'll see people interpret odds ratios as, like, for example, with the estimate of 103, they might say the probability of getting lung cancer when a person's a smoker is 103 times bigger than one not a smoker. But you got to remember it's odds, not probabilities. So we're not talking directly about probability. So it's not 103 times bigger probability. It's 103 times bigger odds, which odds are built on probability. But to be correct and to actually be talking about what odds ratios are, we want to talk in terms of the odds, because that is what it is. Hopefully this helped address some of the questions with this. As always, reach out if you have questions. This is not a major part of this course, but it is one that can be very common in a lot of fields. You'll see odds ratios in several fields. And I wanted to give you this foundational understanding so that you could understand the literature and talk about it in a knowledgeable way when you do encounter them in practice in your field as a clinician or in industry or whatever you end up doing with your career.